Last time we were together, we were talking about ellipses, and we looked at this GeoGebra applet that was showing us the 4 different curves or conic sections you get when you slice this double napped cone with a plane. And we start off here at the circle, and then we saw when we tipped it, we were getting this family of ellipses. And remember that this double napped cone actually goes on forever and ever in both directions. So even after the applet makes it look like these ellipses are being cut off, anytime something is green on this applet, it's an ellipse. And then once I was able to match the angle of the plane to the angle of the cone, the curve turns red and we've got ourselves a parabola. And I said in class that these are the regular old parabolas that we spend so much time talking about in high school, just the x squared kinds of graphs. So we're not going to spend too much time on them. And today we're going to talk about hyperbolas, which is what happens when you go a little bit past the parabola angle and the plane starts to knock into the top half of this infinite double napped cone. And we have to go a little bit far for us to see the top half. There we go. All right, so a hyperbola is going to be a curve. It's always going to have these 2 branches, and it kind of looks like 2 parabolas, but the shape of a hyperbola is fundamentally different from a parabola. And you can start to notice this as you make this angle a little bit steeper. So as I go a little bit steeper towards the axis of the cone, and now I look at this hyperbola, you can see that the branches of the hyperbola are a little bit pointier at that vertex and that the sides are almost completely flat as they go away from that vertex spot. So here is the hyperbola Desmos file that I posted in our resources for the week. And I want us to take a look at the equation of a hyperbola and figure out, just like we did with the ellipse, what the different parts of the equation are doing to the graph of the hyperbola. So we've taken that white curve that was living in that plane on the GeoGebra applet and kind of laid it down flat in our XY plane here. And if you look at the upper left-hand corner, you see the equation of a hyperbola, and it should look just like those ellipses that we were doing in class last time. The only difference between the equation of an ellipse and a hyperbola is that sign in the middle. So ellipses had a plus sign in the middle, hyperbolas have a minus sign in the middle. So we still have that h, k, a, and b. The h and k are going to do the same thing they do with our ellipses. So if I turn on that hk, remember that's not actually a point on the hyperbola, it's the center of the hyperbola where there's a bunch of symmetry about that point. And you can change the values of h and k the same way you do in an ellipse. So I have these sliders down here, so you can kind of watch the sliders. So I have x minus h. So if I wanted to move the center, the x coordinate of the center, I could just move that h around. So if I slide it to a positive number, like here we've got x minus 2, that gave us an x coordinate of 2 for my center. If I wanted to move the y coordinate, I could move this k. So it says y minus k. So let's say I go to k being a negative number, like k minus 3, then that would make the equation say y plus 3. And we would get that center at 2 comma negative 3, the same way we did with an ellipse. So that part of this is going to look just the same. Obviously, we've got a different shape here, and that a and b are going to be doing different things. So let me move the center back to 0, 0, so it's a little bit easier to see. And we'll see if we can figure out what the a and the b are doing to the graph. All right, so right now I have a set equal to 2, and you can kind of see where this shows up on the graph. Right now, this hyperbola is going through x-intercepts at 2 and negative 2, and sure enough, if I drag this a little bit further, so if I make a equal to 3, now it's going through 3 and negative 3. If I go all the way to 4, goes to 4 and negative 4. So that's part of what that a value does. It also kind of changes the shape a little bit. And then the value of b, that one's a little bit harder to see. As I slide b around, it's definitely changing sort of the wingspan of this hyperbola, but it's not exactly obvious what's going on here. So let me put b back at 3, and I'm going to scoot a back to 2. All right. And I'm going to turn on this folder that you can see that says box. And this is going to draw us a box. It's a red dotted line box. It's not actually part of the graph. So notice the size of this box, though. From the center at the origin, we've gone 2 tick marks in each direction on the x-axis. That's the distance of a in each direction. And then I've gone 3 tick marks in the y direction. Okay, that's the number that's underneath the y term, that b that's being squared. So we're making a box that goes a in each direction in the x direction and b in each direction in the y direction. And then I'm going to turn on my asymptotes. And like all asymptotes, these are not part of the graph. They're just a boundary for the graph, but you can see how we would create them. They go through the corners of this box that we've drawn, and they head right through the center of the hyperbola. And these asymptotes, I mentioned that the shape of a hyperbola is kind of flat on the sides. If I zoom way out on this hyperbola, you're going to see that the hyperbola is really looks no different than its asymptotes. Eventually, this graph looks just like its asymptotes. And the only fundamental difference happens when we're zoomed in near the center of the hyperbola. The last thing I want to point out about this is the way that this hyperbola opens. So notice that it's opening towards the x-axis. If I move the negative sign on the hyperbola equation onto the x term, so if I move the negative sign onto the x term and change that positive to the y term, then we'll have the same box and the same asymptotes. It's just going to open towards the y-axis. So we'll be able to tell which way this hyperbola opens based on where the negative is in the equation. So let's see if we can remember everything about the equation of a hyperbola that we learned on the Desmos file. So again, this equation looks just like that of an ellipse, except it has a negative in the middle of it. So we know that it's going to be a hyperbola. We can locate the center of the hyperbola the same way we did for circles and ellipses. So we just change the sign on those numbers in the parentheses squared for x and y. So I know that my center is going to be at a +1, comma, a -2. Again, I'm just looking at these numbers up in the formula, changing signs on them just like we did for ellipses. So I'm going to go to the point 1, comma, -2 and put an x there to mark my center. So 1, comma, -2, and there's my center. All right, so to draw a hyperbola, you need to be able to create that dotted line box. And the dotted line box, its dimensions are defined by those numbers A and B. And those are the numbers that are being squared down in the bottom. So if I look at these numbers down here, this means that I've got a 5 squared below the x term and a 4 squared below the y term. So I'm going to start at my center and I'm going to go 5 units in each direction in the x direction. And then I'm going to go 4 tick marks from the center up and down in the y direction. All right, so I'm going to start off at my center and I'm going to go 5 tick marks in the x direction. So 1, 2, 3, 4, 5. And then in the negative x direction, 1, 2, 3, 4, 5. And then from the center, I'm going to go up 4 units and down 4 units. So I'm going to go 1, 2, 3, 4 up and 1, 2, 3, 4 down. And then I'm going to draw that dotted box that's going to define my hyperbola. All right, once you've got your box drawn, you want to draw your asymptotes. Remember, the asymptotes are going to be those dotted blue lines that go through the corners of the box and pass through the center of the hyperbola. So we're ready to draw our hyperbola, and we need to figure out first which way it's going to open. So look at the equation. We've got the x term is positive and the y term is negative. So that means that this graph is going to open up in the x direction sideways. So I'm going to start off where my center is. I'm going to go out to the box, and then that's where those vertices are going to be for my hyperbola. So from the center out to the side leads me to this point at 6, -2, and over at -4, -2. So that's where the vertices of my hyperbola are going to be. And then I'm just going to fill in and follow those asymptotes off to the side. The main things that I'm going to be looking for when I'm grading your graphs of hyperbolas is, do you have the center in the right place? Do you have your box and your asymptotes in the right place? Does this open up in the right direction? I'm not going to be super picky. Did you get the perfect hyperbola shape?